Welcome, guys, again to a little bit of discussion about mathematics for Algebra 1. And this is a great review for Geometry 2 or even Algebra 2, because we all need to have a good understanding of what it means to be a parabola, a quadratic, and how you can go about utilizing a graph and some information about the equation, no matter what form it is in, to kind of analyze the path or the picture that you're presented with in terms of a quadratic. Okay, so here we go. We're going to use this graph that you see in front of you to talk about some key features that you can find when an equation is in standard form. And standard form, remember, is anytime, I'll get this back to a pencil that is going to work. Here we go. Sorry about that. Here's your standard form. So anything that looks like y is equal to ax squared plus bx plus c. So what we're going to be doing is we're going to be using these values of a, b, and c, these numbers right here, to kind of take a look at what a graph is going to look like. And what I did is I went ahead and made the graph and the equation so we can kind of see how the two are connected. Okay? Because sometimes you may have the graph and sometimes you may have the equation, but you may not always have both. So first of all, here are our x-intercepts. It's where it crosses the x-axis. So we want to always name those in terms of the coordinate point. So this one is 2, 0. And then this one way back here, you can see where it's crossing the x-axis. Remember, this is your x-axis, is at -4 and 0. Okay? So those are called zeros of the function. Those are called roots of the function. Those are called your x-intercepts. They have lots of names, so you kind of have to keep track of all of those terms, meaning that is what you are looking for or solving for. The y-intercept we see is down here on the y-axis. Okay, right there. And it looks like our y-intercept is at 0, -8. And what I want you to notice about this y-intercept is it can actually be seen in our equation as the c value right here. So anytime you're in standard form, that c value is going to give you your y-intercept. So that's a nice thing to know, that you can just look for it and find it right there in your standard form of your equation. Now, the axis of symmetry, this axis of symmetry is going to be that line that cuts your parabola in half and sort of would fold it over like a butterfly. So we look at this line that gives you a mirror reflection on one side to the other, and you can kind of see it happening with your x-intercepts here. It's 1, 2, 3 boxes away to this intercept, and 1, 2, 3 units away to this intercept. So you can tell those are exactly equivalent across that axis of symmetry. And we can use that axis of symmetry and this particular formula. The x value of your axis of symmetry and of your vertex, as a matter of fact, can be found by taking -b divided by 2a. And so what we'll do is we'll grab the b value of 2. We're going to do the opposite of 2 divided by 2 times our a value, which is 1. And -2 divided by 2 is going to be equal to -1. And that is going to be the x value of our vertex. It also happens to be the space, the place where that axis of symmetry is located. You can see it right here is the -1. So we can actually write an equation for this line, and the equation of this line is going to be x is equal to a -1. So that is going to be the equation for your axis of symmetry. And because our vertex is located way down here, it looks like it's going to be a minimum in this case. We can actually find that point. If we didn't know it already, we could actually find it by plugging -1 back into our original equation. So we're going to try that here. I'm going to switch up colors so you guys can kind of see this is a little bit different. And here we go. So y, value of our vertex, is going to be found by taking -1 and squaring it. So just plugging that -1 into my formula, 2 times my -1 minus 8. So -1 squared is 1, plus -1 times 2 is -2. And we're going to add a -8 to that as well. So as you combine your integers here, we get an answer of y is equal to -9. And we can see that that's true right down here. Here's my -10, here's my -9. So -1, -9 is your vertex. Ta-da! So lots of stuff going on here with this problem, and a lot of things we can do with our knowledge of what these A, B, and C values can be used for. Another really cool thing you can look out for is when you see your A value here and you know it is 1, a positive 1, there's going to be a difference between how your parabola looks if the A value is positive or negative. So if your A value is greater than 1, okay, so greater than 0 actually, you're going to have a minimum like that. There's going to be a minimum, and you are going to be able to tell that your parabola is opening up. If your A value is less than 0, then what is going to happen is your parabola would be opening down and you would have a maximum at your vertex. So these are all things we can know and understand just by looking at your A value in standard form and in vertex form, as a matter of fact, so, and in factored form. So that A value, that multipliers, really becomes important in knowing how your graph is ultimately going to look. Okay, I kind of drew through my domain right here. I think for the domain for this one, I'll just jot these down real quick. We're not going to go into a huge discussion of domain and range right at this point in time, but our domain is -∞ to infinity, and it looks like our range because we start seeing our graph here at -9 on that y-axis is going to be from -9 to infinity. Okay. So look at all the things we can do with standard form. It's actually amazing. It's a great form of our equation. We can also use standard form when we learn about the quadratic formula, which we'll be learning about soon. And here, just for the fun of it, I brought in a couple of pictures so you could see them of parabolas in the world around you. So that's the St. Louis Arch. A lot of these water pictures, you can see that as the water droplets go up and come back down, that's going to form your parabolic curve right here. A lot of parabolic curves used in architecture. And then kind of anything that goes up must come down kind of follows a parabolic pattern as well. So I like this one of this skier getting up in the air here and coming back down. I can't do that, but that's okay. All right, maybe some of you guys can. All right, that's all I have for you for today, guys. Hope you enjoyed key features of quadratics in standard form. All right, give you a little smiley face there. Good work today. Take care.